Thanks everyone for attending today's OCP networking panel on automation and orchestration. This is Xin from Microsoft. I have Omar from Facebook. Together, we are going to host this panel. We have 4 panelists coming from 4 individual companies. Before we start, we will invite them to introduce themselves to you. The first one comes from Appstra. It's Sasha.
Hi, my name is Sasha Ratkovic, and I'm founder and CTO of Appstra. Appstra builds a platform and a set of applications for the data center network infrastructure, and it is used by both network architects and operators to automate operation of their data center, which includes all phases of service lifecycle, including designing, building, deploying, and validating their data centers. So why is this important? Well, as organizations digitally transform, they're experiencing a painful trade-off between agility and reliability, and they're pushed to make changes quickly to meet business demand. But then they're risking causing outages, and we are all aware of many stories over the years of catastrophic outages caused by operators making changes quickly to meet deadlines. So reliability becomes an important issue, and the primary source of failure is a human error. Appstra addresses this by providing a unified automation tool that both architects and operators can use, bringing them together so they can automate the design, build, deployment, and operation of their infrastructures. We were founded in 2014 and are proud to have a number of Fortune 500 customers and large deployments scaling to hundreds of racks. This is also an acknowledgement that the focus on building the right architecture paid off. And crises like the one we are in today highlight the importance of this technology, because organizations that are distributing their data centers to meet demand and be closer to their end users wouldn't need to have engineers be present at every distributed data center location. Products such as AOS enable composing IT infrastructure out of best-of-breed components in a reliable fashion. And by enabling this reliable change and evolution of the infrastructure, AOS also prevents you from creating the new legacy, because in the absence of dealing with change reliably, even your beautiful greenfield will turn into brownfield overnight. Thank you very much for inviting us, and we are excited to be part of this panel.
Thank you, Sasha. The next one is Yanping from Facebook.
Hi, everyone. I'm Yanping Li. I'm a software engineer from network platform team at Facebook. At Facebook, we build and bring a family of video-enabled real-time applications such as Facebook app, Messenger, Instagram, WhatsApp, Oculus, and more to millions of people around the world. Facebook's mission is to give people the power to build community and bring the world closer together. Behind these high-demanding applications and services is our production network. We have been growing our global-wide backbone networks and edge network points of presence for more than a decade. Our data center networks also have grown from a handful of regions to more than 15 locations around the world. Personally, I joined Facebook in 2015. From a pure software engineering background, I found a huge space for innovation in network management domain, particularly for network orchestration and automation. On one end of the spectrum, I have been working on building software solutions to facilitate deployment across different parts of the network topology and across IP and optical switches. On the other end, I also have been working on creating the orchestration framework for services and tools and human decisions to work together for efficient day-to-day operations to keep the network running. I'm very happy to be here today with the rest of the panelists together to share our thoughts on this topic. Thank you.
Thank you, Yanping. Next one comes from Microsoft, Prince.
Hey, I'm Prince Sunny. I'm a software engineer in Microsoft, and I'm involved in various open source projects and activities initiated by Microsoft. I do have quite a lot of design and development experience with popular networking operating systems and various switches. At Microsoft, I work for the Azure team, and as you know, Azure is constantly and rapidly expanding. So I'm involved in the testing, automation, and deployment of the switches and routers to our physical networking. And I'm so happy to be part of this panel, and thank you.
Thank you, Prince. The last is Alex from Netris, previously known as xCloud. Alex, would you like to introduce you to us?
Yeah, thanks. Thanks everyone for watching this OCP session. I'm Alex Arian, CEO and co-founder of Netris, formerly known as xCloud Networks. Public cloud is part of everyday life, and in public cloud, users are dealing with services, not specific device configuration. Users are defining services such as, I want a VPC in this region, in this placement group. I want this load balancer in front of my server farm, and then cloud platform automatically makes relevant configurations across multiple network devices and systems to get requested service operational. At Netris AI, we are working hard enabling the same user experience for private networks. Our customers define services, not a NOS configuration, and we assure customers to turn that user-defined service into the safe and validated configuration across multiple nodes and multiple systems in an automatic way. There's no one single network operating system that can be sufficient for all possible use cases for our customers, and so we're dealing with multiple nodes. One NOS is suitable for some use cases, and another is great for a bunch of different use cases, and often you have to deal with multiple nodes even inside single deployment. With no visible difference for the customer. It's a challenging task that we are solving, and we are happy to be part of this panel and share our experience and learnings.
Excellent. Thank you, Alex. So all of you coming from either working with customers to help them to deploy, manage the network, or you manage, orchestrate your own network. So the first question is very common. We have seen many people ask. If your network have many different type of NOSes or heterogeneous network switching hardwares, how do you handle the deployment? What is the difficulty during your daily life? Can you please share some insight with us? Let's start with Sasha. Sasha, you need to unmute.
Yes. So, thank you. AOS for Appstra operating system allows user to express intent, which broadly includes services, policies, and constraints, and this is expressed in vendor or OS agnostic manner. Then within AOS, we have a concept of reference design, which is a behavioral contract that explicitly specifies how is this intent for services and policies translated into enforcement mechanisms. So the reference design first serves as a decoupling mechanism between the services and enforcement and making intent portable across different infrastructure or private and public cloud, for example. And this mapping includes a generation of configuration using what we call model-driven templates approach. And what separates model-driven templates from the traditional scripts-based configuration template is that the parameters for the templates are derived from the real-time state depository, and availability of this timely context enables validation of preconditions. And examples of preconditions are, for example, resource validations, resource identification to avoid fat fingering, or protection from the fact that someone else may be at the same time performing something that is conflicting with your intent. So the main configuration on the configuration side, the main benefit on the configuration side is the reliability of task execution. But even more importantly, AOS provides closed loop validation. And what that means is that similar to test-driven development practices, AOS starts generating from this real-time context expectations that need to be met in order to declare the task successful, and then auto-executes these validations tests and generates anomalies when expectations are not met. And these are not just configuration validations, but validations that all the artifacts that should result from a task are indeed there. So for example, AOS does not only configure BGP session between leaves and spines in a data center, but validates that these sessions are up and in correct operational state, that there are no missing or extra sessions, and that the content of routing tables is as expected. And this in-depth analysis clearly often results in a flood of SIPTAs and conditions which may be overwhelming for the operator. And the key benefit that AOS brings in this situation is the ability to then classify these conditions or situations to watch in plain English into symptoms which are observable but non-actionable artifacts, as you cannot fix them, and then root causes which are way more important and actionable, and fixing them removes possibly hundreds of symptoms. So instead of seeing a sea of red alerts on your so-called single pane of glass, you see only important actionable root causes in what we call simple pane of glass. And we want to point out that this reference design that I talked earlier about is that explicit behavioral contract that translates intent into enforcement mechanism. And the explicit nature of this translation, which is fully captured in the contextual graph model and in a timely real-time fashion, is the fundamental enabler for precise and accurate root cause analysis of the operational state. Thank you.
Okay, thank you, Sasha. So seems like EOS validation all the configurations, make sure that the intent base is very important. Actually, that's a key point when you have a heterogeneous network, when you have different configurations. That's a great point. How about Yanping? From Facebook point of view, I guess you also have a large network, you have different generations of hardware. How do you handle the deployment to different hardware generations or even different softwares?
I guess it might be helpful to think of 3 layers. And I'll start at the bottom layer first, the very basic layer of deployment, where we're talking about device configuration and the code push. To facilitate our automation to handle a heterogeneous mix of vendor switches across IP and opticals, we build a unified interface to interact with devices. The name is FENet Command Runner, or FCR. It is a highly scalable script service for pushing configurations and code to run and running commands in a large scale of devices. FCR can handle connection management and protocol and different protocols and interact with the device connectivity awareness. If you want to know more about FCR, we open sourced FCR in 2017, and you can find it from GitHub. And now if we zoom out a little bit from the configuration and the code push to the second layer of device provisioning, at this level, there are multiple sequential and automated steps of operations. For example, to configure device, we first need to get data, such as device information, topology information. And then with this information, we will find the right image to upload to the device and wait for its reboot. And the next step would be to generate the configurations and push to it. After that, we'll run auditing and validation to make sure the device status as what intended state would be. To facilitate such automation, we need to provide a framework for engineers to specify those steps and run them reliably and predictably. For this, we have a software solution. It's called vending machine. The idea of vending machine is that you give a device role, location, and a platform. Just like a software drink vending machine, it will pop up a soda can. This vending machine will pop up a freshly provisioned network device with zero touch. So I think we have a developer's blog that describes more details about vending machine. So if now we zoom out even more to the third or the highest level layer of the device provisioning process, it's oftentimes that device provisioning is not an independent operation. At this higher layer, is the underlying intent of what is being deployed or updated. It can be part of a fabric deployment. It can be part of a topology migration. In many cases, there are more to do sequentially or in parallel. More people from different teams are involved, and more human decisions are needed in the process. You can just visualize how hard it is to migrate a whole building from our previous fabric design to our new F16 design with new devices, objects, nonces, topology layers. And so to facilitate this level of automation, we provide a end-to-end workflow orchestration framework for our engineer to build their workflow automation that can interact both with the tools and the services and with human decisions too.
Okay, thanks for sharing, Yanping. That's great with different tiers of toolings to help you to achieve the deployment, safe deployment particularly. Next one, let me come to Prince, which also from the Azure networking team that Azure has a extremely large scale of deployment. Can you share some of your experience?
Yeah, sure, Shin. I think in this topic, I would like to talk two things. Like one is something prior to the deployment, and one is once we have deployed it in production. So, basically, what we have done is we have made sure and automated a lot of testing that that we do to qualify different NOS softwares and different switching hardware. And we, once it is qualified, and we have something like the pilot clusters where we deploy these different hardwares and softwares, and then make sure that it is ready for production. So that's at a high level prior to the deployment. And in deployment, we have softwares like graph services and data services that pushes the configuration and have an automated way of handling various network operating systems. So it's not like a separate service for each node, because it has to be like a node and hardware agnostic. So we have configuration and graph services that are automated to push these configurations. Now, on the running production deployment, what we also have is something like, dig into various syslog messages and things that these different software generates, and then we validate on these kinds of like logs that that is generated by these noses. So essentially, we do have highly automated scripts and configurations that handle the deployments. Yeah, I think that's what I would like to share.
Yeah. Okay, thanks, Prince. Let's come to Alex, that from Netris. Could you please share some of your insight?
Yeah, sure. Sonic, Cumulus, pure like Linux system running a switched left driver or DAND, all are different Linux-based nodes running on OCP networking gear, primarily using FRR as a routing daemon. Some switch models can even run like all of these operating systems, and even in this case, there are lots of differences that we need to take care of. There are several like classes of differences, if you will, and each requires a specific approach. So one class is the variations of naming, like different interface namings, like SWP versus ETH, or interface numbering, like some systems are starting from 0, others are starting from 1, or some systems have like just a different crazy, counting systems, which may not sound like a big deal for a human configuring just a handful of switches, but for an automatic network operation system, it's something that needs to be definitely normalized. And how we normalize this particular class is by holding our own flavor of interface of namings in general that we expose to our customers, and for every NOS we have sort of a template for mapping NOS-specific namings into our normalized namings. Another class of differences is how different protocols behave in different NOS. Sometimes normalization is achieved by generating just a right NOS-specific correct set of commands and parameters. But in some cases, we have to complement some shortcomings of particular operating system, like, for example, create our custom flavor of Orchestration or refined version of some Linux tools like if reload, or fix some bugs in routing daemon. And by the way, fixes that are not too specific to our product, we always submit to upstream. It's much harder to take care of normalization closer to a hardware layer, like, for example, TCOM size is a tricky example. Sometimes we have to run sort of sanity checks to make sure that we're not configuring beyond what can fit into TCOM of particular switch model. Sometimes there are ASIC specific aspects, like, for example, SVI for VXLAN is a good example. The internal implementation of VXLAN in some ASICs requires a particular configuration, and otherwise things will break. We do some substantial amount of testing and validation of our algorithms that are translating service models, customer-defined service models, into running configurations to make sure that we're not risking our customers' infrastructures.
Thanks for sharing, Alex. This is a very good point. And also, this is a good setup for the next one, since that you're handling different OS, they have different behaviors. You have to normalize it, to double check it. So it actually leads to our next question. From your experience that you have to deploy different type of NOSes or hardware models, what is your feedback to them so that they can give your life, make your life, or make all the developers' life who needs to deploy it, who need to orchestrate it, to be much easier? Do you mind? Let's start with you, Alex, since you are at this point, to see if you can give some feedback.
Yeah, sure. That's a great question. So for us, particularly given our use cases, the most important is stable operation of essential core functions, and how we define essential core functions is all around layer 3 fabric use cases, things like BGP unnumbered, things like VXLAN and EVPN. Ideally, with full implementation of ESI support, of SVI for VXLAN, this type of things, and FRR is preferred routing daemon for us. So we love seeing FRR growing. We're also one of the contributors, and we love to help everyone to make FRR better every day. It's always good to stick to standards. Like we love seeing how FRR is close to standards, and it's also great when in terms of standards, it's also like we like to see that physical things are sticking to standards, like the last ports of the switch are upstream ports versus in some cases some middle located ports are upstreams. That works, but that introduces some additional challenges. It's good when like the breakouts works in a standard straightforward way versus sometimes breaking some logic. That's also complexity for us. it's super helpful when we can measure things, like whenever we configure something, we always want to, get some feedback, either from metrics or whatever is in, whatever means to read the state. ASIC states, particularly, like visibility into data plane is a great thing which is becoming more and more popular, that we love to see, and we're a lot focused around that, and all kinds of telemetry improvements are of a significant help here.
Excellent. Yeah. Thanks. Standardization using telemetry to monitor them are very good points. Yeah. Let me come to Sasha. As Appstra also are working with customers to deploy, deploy different choices. Either AOS also you could have other choices, and also hardware choices. You are handling a lot of hardware choices. What is your feedback to these developers that they can make your life easier?
Yes, thank you. So there are a couple of points. So you see, in intent-based networking, it brings you ability to declaratively specify the desired outcome for the service. And that makes it easier to consume and manage services. But then there is this hard work of translating that declarative network-wide intent into device vendor-specific enforcement mechanisms. So on the configuration side, this translation would be much easier if device configurations supported declarative configuration as well. And what that means in plain English is that I should be able to express what is the desired configuration state on a device and push it to a device without having to worry about how to get there given the current state of the device. And the device should be the one that takes the declarative desired state and figures out what are the required steps to get it. And in terms of support, some vendors and OSs are obviously better than the others. And while AOS is today performing this translation from declarative to imperative when needed, it is clearly a great benefit. We would rather spend more time developing features that allow users to perform differentiating and innovating activities using AOS as opposed to doing this undifferentiated heavy lifting. And then in terms of analytics, again, AOS does a lot in extracting knowledge out of raw telemetry data based on the knowledge of the end-to-end context. But at the same time, there is quite a lot that could be done at the device level and by the device that would enable easier scaling. So namely, there is a lot of aggregation and knowledge extraction that requires local device context only, and this analysis should be done on the device if device is instructed to do so. So if you take, for example, ECMP imbalance, all the context required to assert that the imbalance exists is on the device. And processing data as close to the source as possible, in this case device, would also help overall resource and network traffic consumption. And when we talk about aggregation, we also mean ability to define some conditions and be simply notified when that local condition occurs, as opposed to fetching the data across the network continuously, processing possibly non-interesting data most of the time in order to capture some condition that could have been identified on the device itself. And of course, as others have mentioned, there is this usual benefit of exposing this data and leveraging set of standard languages and streaming protocols such as YANG and OpenConfig. And this has been a long-standing ask.
I see. Thanks, Sachin. Yeah, this is great. So next one is Prince and Yanping, you both have been on the hypercloud side. That you work on the OS as well as deploying it, as well as you use upgrade your network using different hardwares. So how about from your point of view that you're thinking to give to rethink what can be done better or for the hardware or both software so that to make this deployment and orchestration life easier? How about Prince? Would you like to go?
Yeah, sure, Shin. So, like you said, being involved in various deployment and debugging of the noses and hardware. One thing I would like to highlight here is I would expect a good documentation on the software side that can be of a good reference. That's one thing, and especially the debug utilities. Like for example, there's this control plane, data plane issues, and we would like to have the proper debug utilities to check such things when we encounter an issue on a particular device or particular OS versions in production. The other thing is in Azure we have heavily invested on automating the alert mechanism. So we do check on the logs and any kind of utilization, etc., that the vendor OSs generate. So when we do some kind of upgrades, I really would expect to have some kind of backward compatibility and to not break the previous because we would have already deployed these things and is running in production. So if some changes happen, then it will kind of impact our alerting mechanism. So such kind of standardization, documentation, debug utilities is what as an engineer who's involved in these kinds of deployment and debugging, I would like to highlight. Yeah.
Okay, thanks for sharing, Prince. Let's come to Yanping. How about from your side? Can you share a few feedback or insights?
Sure, I'd love to. I think the first thing I would like to highlight, as Session mentions about the open config, I think I would like to ask a set of unified data models and APIs to read and write both configuration and operational states across different vendors and nodes. Open config can be one of the promising one. If we can have such a well-adopted unified interface, we will be able to greatly simplify our software solution in network modeling, in configuration generation, and also in operational tools. And we can enable our engineers to build automation faster. I think the other another thing that I'd like to ask is more specific to a particular set of devices, the optical devices. We would like to ask for increased optical switch interoperability and programmability. At Facebook, we put great efforts in managing our optical network. Ideally, we would like to be able to provision, deploy, and operate our optical gears with the same level of automation as we can do with IP devices. But at the moment, many steps needed in the automation for both deployment and operation would be almost like a research project for our engineer. For example, how can we easily, reliably retrieve a full device config from an optical switch? To store a full device config is very critical, thinking about in a disaster recovery scenario. And also, how can we easily and reliably push a full device config to an optical switch? All this kind of capability can greatly simplify our deployment automation. Thank you.
Excellent, thank you. Yeah, thank you. This is hopefully you will find these feedbacks or insights from this panelist and is like informative for your work or for your future development. Again, let's thank our panelists. We have Sasha from Appstra. We have Yanping from Facebook. We have Prince from Microsoft. We have Alex from Netris.ai. Thank you so much for your valuable time to come here to share your experience with us. And then by the next step, we will stop here and start to take questions from the audience, either from the chat window or you can raise your hand. Thank you. Hey guys, can you hear me?
Yes.
There is a question coming on the chat window from Megan. How do you recommend it to automatically operate networks in order to minimize the operational overhead, especially with multiple nodes? Not to learn every specific command of every node and every detail of new releases. This actually is a very good question, very practical. Let me come to the panelist to share some of their insight with us. I see Alex, would you like to go first?
Yeah, sure, I can. So thanks for the great question. In tribal answering in scope of using our product, it's of course different for every case, but in our case, the customers which are using Netris, so it depends on the level of their knowledge and level of how advanced things they need to do. And actually, for the customers who want to do some advanced things and they are familiar with the specific commands, they still can apply this knowledge, and that's a lot helpful. But also for the customers that don't have that specific detailed knowledge, and that's not critical for their business. What they want to do, they want to focus on architectural level to define what they need to do, but not actually how to do. And in this case, if this is the case, and using the Netris, they don't need to know all these specific details. They basically define this high-level service type of things and architectural type of things, and Netris takes care for the configuration of different nodes. And it's interesting that you also mentioned about new releases. I'm assuming that's with respect to new releases of NOS. So how we do that, when we ship our product to customer, we always say that these are the recommended versions of network operating systems, and we really strongly recommend to stick to these versions, because we know that we have validated our configurational templates with these particular versions. We always keep this up to date, of course, but I mean, versions are important because sometimes some versions may expect some different actions by the users, and if you are using automatic operations tool, you want to make sure the tool understands that updates to the particular version. So happy to discuss on this further. You can find our booth, Netris, and would be happy to dive deeper into this topic.
Thanks, Alex. Let me turn to Sasha from Appstra. Would you like to share some of your experience?
Yes. So very good question, Megan. So this is precisely where intent-based networking comes in, because you specify what is the value that you're trying to extract out of your infrastructure, what is the service, and what are the parameters of the service, and you want to not have to deal with every command on every NOS. So the way Appstra operating system deals with this, and we have this concept of reference design, which each device plays a certain roles, and it's job of AOS to translate the service intent into device configuration. So actually, you don't need to even know anything about this device configuration and specifics of the commands. And again, because it's a top-down approach, we model the features that are actually useful for the customer. And when there are changes in features, it's done under the cover. So customer is not even aware that there has been a change in a command or whatnot, because that change has not propagated to the intent. So again, intent is that abstraction layer that decouples you from having to know the details of every NOS.
Thanks, Sasha. Let me ask anyone else who would like to add on to this question on the node side. If we have multiple nodes, multiple versions.
Yes, Shin, this is Prince here. Can you hear me?
Yes.
Okay, great. So one thing I want to highlight is this is exactly something that we have solved in Azure. So we have something like the graph service and the data management, which will create a graph based on the topology and the role of the device. And the graph is like a single unique one. And basically what happens is you convert this graph to a device understandable format. So that happens in the background. So basically the network administrator doesn't have to know about each of the commands in the nodes, but this service will take care of converting it into the device understandable format. So that's something we have in production and in deployment for Azure. Yeah.
Thanks, Prince. Anyone would like to talk, please, before I go to? Hi, Yaping. Yeah, we can hear you.
Oh, cool. So that's Yamping from Facebook. This is a very good question, actually. In two sides. For one is on the configuration time. We do, like Sasha commented, we do a top-down approach to generate our configuration based on our intent. That can bridge a lot from different versions of different network operating systems. But also on the operational side, we also want to automate some like troubleshooting process where we do need to depend on certain things that would have variations between versions, particularly different releases of the operating systems, and that really gives us some pain sometimes. And for example, some prompt difference into when you connect to the devices, and they can that can break the automation. And of course, automation should practically should theoretically not rely on some mainly the interfaces that are developed mainly for users, but in practice we do have many operations actually depends on that. So it will be great that we can keep backward compatible between the releases of the network operating systems to that end to facilitate our operations. Thanks.
Thank you, Yaping. Great. Let me move to the next question from Ben. The question is, we have heard feedback about importance of standards like OpenConfig. We'd love to have the view from the panelists. So I'm turning into our panelists. Again, let's start with Sasha.
Yes, so I have mentioned actually in my presentation as well that it is very important, and the reason for that is it reduces the amount of work that has to be done by the automation solution having these standard protocols, which means that we can focus on value-added activities. On the other hand, solutions that provide automation should also be capable of handling different types of protocols, because you don't want the standardization to be the limit for innovation. But again, having standards helps greatly, because again, we don't have to perform this adaptation layer, which is not really a value-adding activity. And OpenConfig is certainly one of the protocols that we value highly in this regard.
Okay, thank you, Sasha. Oh, thank you, Alex. Sasha, would you like to share some opinion on this as well?
This was Sasha.
Oh, sorry. Yeah. No, actually, I was asking Alex. Would you like to share some opinion as well?
Yeah, sure. This is a great question, and I think for everyone building automation software in-house, which is eventually taking these units of network devices individually, OpenConfig may be important, and the other standardization. In our case, it's a little bit different, because what Netris is doing, we are bringing public cloud user experience to private networks. So in public cloud, users are not using OpenConfig. They are using tools which are used for configuring cloud. And we do the same. We particularly don't use OpenConfig, and so our customers don't. But in a general case, I understand why OpenConfig is important. And yes, so vendors that are creating switches, they should make sure that switches are stick to standards, and there's as much as possible standardization, including tools and standard protocols like OpenConfig.
Yeah. Okay, Alex. Yeah. So anyone else would like to chime in? Like Yaping? Not sure if
sure.
You're using.
Yeah.
Okay.
So I guess in previous questions I've touched upon that. We do believe that OpenConfig can bring a lot of efficiency in automation. Like I mentioned, not only for the configuration but also for operational status changes. That can help us to get away from depending on some device-specific interfaces such as CLI operations, and by exploring this OpenConfig, we will be able to make our software much more reliable. But we do understand there is a gap between the features that's supported by OpenConfig, and I personally really think we should invest in this, how to bridge these gaps and how to improve this OpenConfig to make it more useful. Thanks.
Yeah, thank you, Yaping. Actually, we have to wrapping up very quickly. We are exceeding, but one more question very related to this published for Yaping as well. People are asking, should OpenR also adhere to OpenConfig?
I think this is a very specific question. I personally don't have more details on the thoughts that we have between OpenR and OpenConfig, how we want to incorporate that. But I would like to, maybe I can find more and come back to Aldrin. Yeah, we can follow up on that.
Sure, definitely. Yeah. Okay, with that, we have to close this session, and the next one will start very soon. Thanks everyone for attending. If you have more questions, please feel free to reach out to the panelists and me or OCP staff to have further discussing. Thank you so much for your time. Bye.
Thanks everyone.